This video is dedicated to a question that was asked by one of the students the other day. The question is, what is a set? The thing is that we actually do not have um, a definition for the concept of a set. In fact, I would go as far as to say this is not even a concept. So the concept that we have is of a universe of sets. And a universe of sets is something that consists of objects, and these objects could be anything we like them to be. They could be concrete objects, they could be parts of our imagination. But that's not all. So just a collection of objects does not make up a universe of sets. A universe of sets is a collection of objects together with a certain data. This data tells us which objects are related with which other ones through something that we call an element relation. So with the data of objects, we also have a data of arrows that represents that relationship. So in terms of the structure, what we've got here is just the data of objects and the data of arrows. So there are no sets, there are no elements at this point. It's just a raw data of objects and arrows. And that's what a universe of sets is. Now, there is certain terminology that we bring into this concept that is just a terminology. So it is not a new concept. The concept is this one of a data of objects and a data of arrows. Something like this is also in a subject called graph theory is also called a graph. In set theory, a data of such arrows would be called a relation. Right, so uh, the notation and the terminology is as follows. So imagine this dot here is called x, and that one is called y. When x is related with y, so let me make this clear one more time. At this point, we've got a data of objects and a data of arrows. So what you see here in front of you is all we've got. This is the entire universe of sets. There's nothing more here and nothing less. And now, in order to talk about these objects, we want to call them something. So let's call that one x and let's call this one y. And when there is an arrow connecting x and y, we're going to say x is an element of y. Now, let's consider this one, for instance, z. And let's consider here a t. Now, one thing we notice about z is that there are two objects connecting to it by an arrow. So we've got y is an element of z, and also t is an element of z. So what we can do now, we can make a different drawing where we indicate the object z, and then we collect all the objects connected with z. So these will be y and t. Since there is no other object connected with z, so that's all we have got here. We can collect them together, and now we can say that this relationship of arrows can also be displayed like this. So the information has been now fully translated into, without any loss or any additions to a different type of notation. And the purpose of this notation is to suggest a certain intuition that we might want to apply when we work with the universe of sets. And namely, the intuition is that, so remember, the intuition is something that is imprecise but something that helps us to think about another thing, even though uh, the things in the realm of intuition, um, they're not supposed to have definitions. They're supposed to have, at least not mathematical definitions. So they're supposed to help us guide in getting ideas and so on, but they are not absolute objects on their own. So the package comes together with the precise mathematical framework and the intuition. Just like intuition on its own uh, would be useless in terms of being imprecise and all of that, and so we would not be able to really make use of it. The framework on its own, without the intuition, would have also been useless. We would not been able to really do any meaningful calculations because of the complexity of the framework. You see, intuition helps us make things easier. And so, with this theory of sets, the intuition here is that an object Z is can be seen intuitively as a set in terms of the collection of its elements. You see, but now there is still a difference between the set and the collection. The collection is just part of the diagram that consists of certain objects, not all of them perhaps, whereas a set is an actual object in the diagram. So there's a difference between collection and the set. And a set is just a name for the object in a universe. In a different universe, there will be different sets, different from those that are in this universe. So that is the answer to the question, what is a set? So to summarize, a set is basically a name we give to an object in a diagram with dots and arrows that we call a universe of sets, obviously related to the idea that we call objects of that thing sets. And the terminology is there for us to help with the intuition that every object in this diagram is uniquely determined by the collection of other objects related to it by the arrow. Um, and that uniqueness of determining an object through its element comes from the axiom of equality of sets. And so, since every object is uniquely determined by that collection, um, we can think of that object as the collection, but it's actually not the collection. So that's why we distinguish between set and collection. Now, if for you this intuition is a bit weird, it's unacceptable, you don't have to adopt that same intuition. You can have your own interpretation of this intuition. What matters, though, is that we agree on the mathematical framework. We agree what a universe of sets is. We agree how this symbol, the element symbol, relates to this picture with the arrows, and we agree how this picture, uh, the expansion of set into its elements, relates to that picture. Or, so that is actually what really matters. And if you find that you want to have your own intuition about these things, you can go ahead and do that. Um, I would, however, find it quite unlikely if you find another reasonable intuition that could be as helpful and useful in dealing with set theory as this one is. Now, from the more philosophical point of view, in terms of the question, why this? Why does something like this work for mathematics as a foundation for mathematics? Well, the answer to that question is that this is not the only foundation. So set theory is not the only way to understand mathematics. It's just one of the ways. It's one of the first ways, actually the first way that provided the unified framework for understanding mathematics. But after that, it was realized that there could be other ways too. However, because of its kind of geometric nature, because of the possibility of drawing things in two dimensions rather than writing things in a linear way in a single formula alone, because of that feature, it becomes quite useful because then we can apply our spatial um, intuition in solving mathematical problems. So my personal take on the usefulness of set theory is that it allows us to apply our spatial reasoning, as I said, in terms of unpacking and dealing with complex mathematical situations and problems. Right, so that's a video on the question, what is a set? And if you're not satisfied with this video, go ahead, try to make your own one. I would be very keen to see what your take is on the question. As I say, set is not a concept. The concept is a universe of sets, and from that point of view, it's a very precise and concrete thing. But in terms of the intuition, um, since intuition is imprecise, one can perhaps refine and do a video like this better than I did. I hope it was useful. I'm looking forward to your contribution. Thank you.